Next, we want to evaluate the limit. Direct substitution gives 0 minus 0 over 0, or 0 over 0. This is a classic L'Hopital's rule kind of problem where you notice that what we start with is impossible to factor out and simplify algebraically. So we're going to apply L'Hopital's rule since it's a 0 over 0 form. L'Hopital's rule says the limit of the original function, if you have a 0 over 0 or an infinity over infinity type limit, is equal to the limit of the derivative of the top divided by the derivative of the bottom. So the derivative of the top is the cosine of x minus 1. The derivative of the bottom is 3x squared. Now we can try direct substitution again. The cosine of 0 is 1. 1 minus 1 on the top over 3 times 0 squared is 0 over 0. Since we have a 0 over 0 form again, we can apply L'Hopital's rule again. So the derivative of the top is negative sine of x minus 0, I'm not going to write it, divided by derivative of the bottom is 6x. Applying direct substitution, we have a limit in the form 0 over 0 because the sine of 0 is 0. So we apply L'Hopital's rule one more time. The derivative of the top is negative cosine of x. The derivative of the bottom is 6. Now when we apply direct substitution, the cosine of 0 is 1, so we have negative 1 divided by 6. It's very important when you're doing L'Hopital's rule problems that you have something that is applicable. The only things that are going to be applicable for L'Hopital's rule are 0 over 0 and infinity over infinity. Now, it can be plus or minus infinities, that doesn't matter. But these are the only two limit forms that work for L'Hopital's rule. If it's another indeterminate form, such as infinity minus infinity or 0 times infinity or the 3 power indeterminate forms, you're going to have to algebraically manipulate it to look like 0 over 0 or infinity over infinity before applying L'Hopital's rule.